Hello, good day, everyone. I'm Dave Rubenstein, Editor-in-Chief of SD Times, and I would like to welcome you to today's program, The Realities and Myths of AI and Software Testing. Joining me today is, in this window over here, is Kevin Surace. He's the CEO of automated testing software provider AppVance. Before we get started, I just have a couple of quick housekeeping announcements. The webinar today includes a live Q&A. So at any point during the presentation, you can ask a question by navigating to the questions tab in your control panel, typing in the question and hitting submit, and we'll answer as many as time will allow. Second, today's program is being recorded and will be available live on sdtimes.com on demand starting tomorrow. So as we've been reporting in SD Times, AI is the buzzword of the day and holds tremendous promise for software development, but also generating the most FUD, as we call it. So AI can help organizations eliminate repetitive, mundane tasks from developers and testers, but a lot of those folks fear losing their jobs because of AI, and of course, we all know about the robot overlords that will be ruling us all soon. Anyway, so we're here to talk about what's real and what's a myth in AI. So Kevin, let me just throw it out to you and we'll get started. What is the reality of AI, and what do folks with us today on this webinar need to know about AI and software testing?
Thank you, Dave, and for the folks out there, Dave and I really want to make this a conversation, right? I've got a few slides here just to make some points, but it's really much more about a conversation of what we've learned so far. We've been delivering some product specifically in this for a couple of years. We've learned a lot, and I want to share some of that with you today, which is great. Dave's got a lot of questions, so I think we can just hit the button and see if we can go forward. So here are some of the topics that we talked about sort of discussing today. First of all, what is AI? I think in QA we can get a little bit off kilter on this, so I wanted to go back to the basics and say, what is AI? What are we really talking about? And then what are the goals? Because it's the goals that are the most important. Whether it's AI or shmai, it doesn't really matter. It matters, what am I trying to achieve? I actually don't care how you get there. If you can help me in my job, I'm interested. It's nice that you want to use the buzzword AI, and I think, as Dave alluded, there is so much FUD. I mean, I think we were the first to really talk about it back in 2017 and bring some product to market. And then all of a sudden there were like 10 people who stuck AI on their website, and we couldn't find any, but it was interesting. And this is very typical in all markets. It's not just this one. So this is exactly what happens, right? And then how does it work? What are the challenges? We've certainly seen a lot of challenges in some areas where it isn't as good, it can't help as much. What do you expect in successful POCs, proof of concepts? How should you think about those and some of the actual outcomes? So I'm going to talk about that and talk about some of the ways we went about solving some of these things. But let's start just overall with, what is AI? I'm going to want to go back to the basics, because most of the people they're watching this webinar later or today live probably don't spend their time in AI. They spend their time in software development or software QA. And so I think it's great to go and say, well, where is AI being successful? It turns out AI is seeing tremendous success in 10 to 20 industries today. Really great success. And there's obvious places you're already seeing it, obviously in speech recognition with things like Siri and Alexa, and also facial recognition, of course, on Facebook. So we're already seeing it in places that are obvious. But medical imaging and marketing and search, and I mean, there's just so many places in fintech that you're seeing great success. So of course, us in QA, all of us in QA, in the QA field or the dev field, say, can we apply this to our problems? Maybe. That's the question. That's the question. That's the answer. So I'd like to split AI into two areas here. One is what we really do, and the other one is fantasy world. So we really, as professionals, need to separate ourselves from the fantasy world. The fantasy world is really driven by scientists, driven by Hollywood. It's general AI that can do multiple tasks, just like a human, that has broad understanding of the world and the problems around it. That's the general public idea of AI. It's Her, the movie. It's Ex Machina, the movie. Great movies, has nothing to do with what we actually work on.
iRobot, one of my favorites, by the way.
Yes, absolutely. I mean, they make great movies. We love the films, but what we need to work on in our industry, and in fact, what's been successful in each industry, is truly driven by industry. It's one task It's very practical. It's very hard to do. It's millions of lines of code to build this stuff. It is not something that you do, really quickly. It's something that a vendor is going to spend a long time on. We spent years on it.
Well,
That's
Kevin, let me just jump in for a second. You touched on it, I think, on your last slide. There's a lot to AI. It's not just one thing, and there are a lot of different uses, as you said, natural language processing or just automating tasks. And I think that's part of the problem of people trying to get their head around it is that it's not just one thing.
Well, that's exactly right. And in fact, I'll talk about the places we use AI. It's 19 different areas. It's not like I just did this and it's AI. And by the way, who cares? I mean, there are people using NLP, right, natural language processing for software QA, and they've developed some new languages that use NLP, so you can kind of write your test in English or something. I don't know that gets us anywhere. Do I really need another language? Some people would say that language is easier than Selenium or I don't know. I don't think we need another language, because even a new language using NLP, has certain constructs around it. So you do have to learn another language. I don't think that's what that's not going to move the industry 50%, 70%, 80% ahead, right? So what professionals focus on is that kind of very, very narrow task set. And Dave, as you alluded, there's a ton of AI/machine learning. And machine learning, when we say AI, I would argue, this is Kevin's point here, you decide if you agree with it, AI is really a marketing term, right? It's really a marketing term. What we're talking about is utilizing machine learning in a way that seems to humans as if it's somewhat artificially intelligent. But in the end, it's machine learning algorithms, and we've been doing machine learning for 50 to 60 years. It's gotten really cool in the last few years because of access to cloud, which means we've got access to thousands of processors for an hour, because that's all I need them, so I don't have to go buy a Cray supercomputer, and because of deep neural nets, which the math for that got really, really quite good in the last few years. So they can be applied in a few areas. When we look at all of the machine learning algorithms, these are some of the most popular. There's about 100 here. There are literally hundreds that we could choose from. Go ahead, Dave.
No, I was just looking at the list here, and it's quite large, quite comprehensive.
It's quite large.
Yeah.
Here's the good news. You, as a QA professional, don't ever have to worry about this. My point of showing you this is that a vendor in the space who has expertise applying machine learning to our space of software development, software QA, has a lot of tools in their toolkit, like an unbelievable set of tools. And this isn't widely known. People think, well, I'm going to build a neural net around recognizing X. That's interesting, but what does that add value, right? Facial recognition on Facebook probably added value, but they had a trick. They had billions and billions of photos already with names on them. So they had essentially a supervised learning situation where it was the world's largest database of faces and names. So they went to work and used that. But we don't have that capability in software QA. The database they had is completely different than we get to use. So this is a great chart, and it's about data size versus model performance. And so you've got traditional machine learning that works with very small amounts of data and works incredibly efficiently. But as you get larger and larger and larger sets of data, like the Facebook facial recognition thing, you want to develop a large neural net, because that becomes the most efficient, as you can see out to the right, right? So again, experts in this field will choose the right tools to use. You don't have to worry about how they did it, but if they did it right, it's going to apply to my next point, which is, what are our goals? And you may have some thoughts about this, Dave, because you've seen a lot come and go in this industry.
Sure. Yeah, it's again talking about the machine learning. So how is that actually? How do you apply those kinds of concepts to Q&A?
Well, I think
trying to achieve.
Yeah. I think
repetitive tasks, or is it actually a broader vision?
I think that's right. Well, let me say, number one, a vendor who is going to produce a product needs to sit down and have a set of goals. The goal cannot be, let's use AI. And I can think of 5 people who went and did that. These are very good people. I respect them. But that's for universities to do. Let's use AI as part of my PhD thesis and see what we learn. Great. But in industry, we have to have a goal to save you time or money or something. Otherwise, why would you ever buy it, right? So that's just me, right? because done this for too long. People buy products that add value. They don't buy products because it's got a moniker of AI on it. So our goal didn't include, hey, let's use AI. It was, could we use AI to maybe recognize objects better? That's an option, right? Help pinpoint the cause of errors. Pretty interesting. Self-heal scripts. Obviously, this is one of the pain points in the industry. That's interesting. Automatically generate tests and find bugs. High bar, but that's the ultimate thing. But in the end, you've got to reduce QA time. And I don't mean put people out of work. That's not what I mean. What I mean is let's take our people and relegate them to way more important tasks, as you'll see kind of in our thinking here. But if you don't reduce the time to do the basic things that they've been doing, I don't know what value you brought. Who's going to buy it? Right. Nobody.
Right. I think some people do go with the goal of let's do AI and see what it can do for us. And those, I think, are the projects that fail very often because they didn't have a real goal. It's like, okay, we dabbled around with it, didn't really understand what we were trying to do with it, so it's not for us.
And that's exactly right. Number one. Number two, also you get people who say, I've got a budget, I'm going to dabble in AI, and I don't have any expectation for outcome other than to learn. That's fine. Right. Dabble, you decide if it does something for you or not. But the vast majority of industry that we all work for, you get a budget because you have a goal of an outcome at the end. And there's some risk to that goal. This is bleeding edge technology, there's no question, but that's what you do. So we looked at where do QA people spend their time? And I'm sure this is different in every company. So some people on here are going to say we spend our time differently, but across the industry, it's actually clear. And this is a broad-based industry survey that 70 to 80% is still manual testing. Then there's a chunk of writing scripts, another chunk of fixing scripts, and then there's those other little things. They're analyzing tests and running tests, et cetera, et cetera. So again, you and your own firm can decide where you spend your time, but across the industry, these are the hours that go into this. And $80 billion are spent around the world today, 80 billion testing software. Most of that is manual. Some of it is writing and fixing scripts, and very small portion are, running tests, analyzing tests, and other in terms of people time. So we said, that's clearly the opportunity, and that's clearly the bottleneck if you wanted to go faster. If you want to take 3 weeks of testing down to 3 hours, I've got to do something in those big swaths. Does that make sense?
Absolutely.
So again, we may not be right. I'm just sharing with you, this was our thinking, and it could be flawed. So we developed a set of goals, and we said, our goals of potentially leveraging AI in QA is not to just leverage AI in QA and put it on our website and say AI. It's actually to try to virtually eliminate test maintenance. I didn't say 100%, I said virtually. So we're going to try to eliminate as much as possible, because even 50% would be a miracle. Generate thousands of valid scripts in minutes. Now that is a very cool thing. And I'll tell you right now, I'll give you the punchline now, it works. We absolutely can generate about 5,000 to 6,000 scripts in 10 minutes now. And we'll show you how we do that. It's very cool. Validate virtually anything through the application under test without writing a single script. So validation is kind of a little bit of a new concept. It means to look for things throughout an application and make sure that they're working the right way, either logically or physically or whatever. Find more important bugs and make this the centerpiece of your continuous test and deploy process. And for a lot of our clients, that's exactly what we saw happen. Immediately, they went from weeks to hours or minutes, and this became the decider in their continuous test and deploy process, which they couldn't have gotten there before because they really needed to sort of speed up what they were doing, right? So I like to think of AI as augmented intelligence. It's not artificial intelligence. It's going to augment what you already do. You're not going to throw away what you do. You're not going to discard what you do. You're not going to ignore what you've done, all the great work you've done. You're going to augment that so that you get much higher coverage, real coverage that's valuable, a much higher validation of your application, doing less work. That's what you want to do, right? It frees the team from manual testing and scripting to really focusing on generating better and more test data, evaluating the test results, and improving the test coverage, not sitting there and going, oh, I got to fix 1,000 scripts before this runs against the new build. That's not a good use of human time, in my opinion, and we've spent 30 years doing that. Dave, I know we've talked about this chart a lot. This chart's been around the industry. I didn't make it up.
Right.
We modified some words, but because we have our own slant on it. But this was somewhat stolen from the SAE, the Society of Automotive Engineers, who developed a 5-level chart for driverless vehicles. And we said, well, and others said before me, actually, how do we apply that to QA? How can we apply it to software QA? There'd be 5 levels of this. Well, okay, that's pretty obvious. Most people are at level 0 today, no automation. The 70 to 80% of testing is no automation, which is fascinating. Level 1 is scripting and coding. We've been there for 30 years. I mean, regardless of the fact that we've gotten new languages a couple of times, Selenium's now 15 years old. It's not new. This is not a new idea. So that's level 1. You don't get a lot of productivity from that, as a lot of people have found out. And that's why so much is still manual. And I know people will argue with me and say, I'm incredibly, I know there are outliers and people are productive, but in general, when you look at the numbers around the industry, we haven't seen huge productivity gains from scripting versus not scripting, again, across the industry. And you do have to step back and go, why do we have, out of $80 billion of spend, $78 billion of people? That's very unusual in a technology field, where normally you see the spend flips to technology and less people. That's what happens over decades, but it hasn't happened in our field. It's just fascinating. And then codeless capture and playback is some kind of advancement. Again, there's big arguments in the industry whether it's good or bad. I would tell you, 3rd generation recorders are nothing like the recorders of old. So if you get to use something that is of a new generation, you might be surprised how productive you are with that. But only a little bit more productive. And then finally, you get to self-healing scripts, which is very cool. And that is a big step forward. They can't self-heal everything, but they can self-heal a lot. And then finally, machine learning that can auto-generate smart scripts. And that's interesting, except you don't have the kinds of validations that your eyes could give you. And finally, you add in validation. So you're generating scripts automatically, you're self-healing them automatically, and you're validating your entire application automatically. When you do that, it's what's called hands off, minds off. And that's the killer. That's where we all want to be. Let the machine do all the heavy lifting, right?
Right.
Any thoughts about that?
It's interesting, because I was at a testing conference last year, and I like to sit with the attendees at lunch and kind of say, what are you here for? What do you need to learn, and that kind of stuff. And the conversation turned to automated testing. And they understood the value of automation on systems where things were repeatable and the data was static, because it just made sense. They had a hard time getting their head around, well, how do you automate something that's constantly changing? And
Right.
And I think that's one of the things that's also holding people back from kind of diving in, because they don't even know how. It's like you have this set of information and you test against it, then all of a sudden that changes. How do you test against that? How do you automate that?
It's a great question, and it's something that we had to really deal with on the AI side. What happens if an application is truly dynamic? That many of the things that happen on many of the pages, if we want to call it pages or screens, whatever, could be different by the second. How do you decide if it's doing the right thing? Now, the way to do that is to go back and say, how would humans do that? How do they do it manually? The value of really good AI is to mimic what the humans do, because those applications are tested today. They're tested by banks of humans sitting there who have been given information on what to look for, right? We know that, right?
Mm-hmm.
So in fact, it is somewhat repeatable, because they're not retrained every day. They were trained that the application changes and to look for the following things. So these applications are getting tested. They're just getting tested in a very slow, laborious way.
Mm-hmm.
So can we mimic what the humans do? So that's how we looked at it. We said, there's already a model to do this. There's already a model, and the model is very clear. It's humans, and they're testing. Yeah. Now, because we've got 2 years now in the field, we were able to go back and say, what kind of productivity improvements can you get, right? Now, obviously, the system's going to generate far more tests than you ever had before, and sort of a whole bunch of other things, and be able to maintain them, et cetera. But it turns out all the productivity comes at level 4 and level 5. There's limited productivity gains, and obviously 0 is the baseline, right? But 1, 2, and 3, in fact, they're so, they're good, but they're so low that on this chart that goes from 0 to 5,000, you almost can't see them, because it's like 1 to 2 to 4 to 7 or something. Anyway, all the calculations are on the left that we used, and we've done a fair bit of measurement at looking at this. So I think it's a fascinating field, by the way, and it's an entire field to just measure human productivity. But real productivity happens at level 4 and level 5, just like it does in a driverless vehicle, because you can be on Facebook all the time, the vehicle's driving you, right? So,
how does it work?
How does it work? So here's how ours works, is what I would say. This is how we attacked it. That may not be the right way, as you continue to hear from me. I don't know. This is what we decided works in conjunction with our clients. So what we found is that your scripted tests do not go away. You will always have some, because they've got specific logic use cases. Even with self-maintenance, you're going to create those cases because you need to go tell management that those absolutely ran. These 10, these 20, these 50, these 200, whatever it is. May not be thousands, but there's some number. So the idea that all of your tests are now going to be generated by a machine, we don't find to be true. And we don't find to be a practical thing to do. But it could be that 99% of your coverage is generated by a machine, while 1% of your coverage, or a small percentage of coverage, is generated, in our case with Test Designer. But those give management assuredness that the application is working the way they want it to be, and the rest give you coverage that you wouldn't want to go do. So let the machine do the heavy lifting, but the people are still going to create these specific logic use cases. The second thing is that, for the most part, test data has to be created by humans, and it has to make sense, so that when the machine comes to a form, it knows how to fill it out with something legitimate, right? Now, our machine can generate data into those forms, but it still has to have a range of what to generate. So there is real work to do around test data. And what we're finding is, if you really want to have great testing, you want a lot more test data than you've ever had, and let the machine write the scripts to deal with the test data. So these work in conjunction. One doesn't give way to the other. You need both. And yes, the machine will generate thousands of scripts. You go, well, how does that work? As I said, we ended up modeling real human testers. Said, what do they do? How do they approach this? Because they've solved the problem. We just have to repeat what they do. Turns out machine learning can be pretty good at that. Today we have 19 areas of machine learning inside the product. And this was a heavy lift. It's about 4 million lines of code, to sort of give you an idea of how big of a platform this is. I always, Dave, in software QA, people call these things a tool, and it rankles me in some way, because I go, no one else wrote something of this size, and when you get into something like this, it's really no longer a tool. It's a system, and it becomes the core of what your QA can be built on, as opposed to, oh, I've got this little tool that's going to help me do this. This is not a helper. It becomes the core of something, right? So you almost have to rethink the way we think about these things.
So this also probably, says to developers and organizations, maybe it's not the best path to decide you're going to write your own artificial intelligence, because the magnitude, of the exercise.
So look, if you're Google, you're going to do this yourself. If you're Facebook, you do it yourself. If you're Amazon, there's no question. But most companies have dozens, hundreds, maybe thousands of applications. And what's unique about this is we had to write this to work with thousands of applications, not one. If I'm at Facebook and I've got to create an AI system to automatically generate and test, some subsection of Facebook or something, that's my total job, and I probably have a $10 million budget to go do that, right? Because the total amount spent on the heavy lift of quality assurance at Facebook or at Google is now in the billions over several years. Billions were spent on quality assurance. So the rest of us don't get billions of dollars to do that. So if someone gave your team billions of dollars, of course you can write your own thing. But this is now approaching, 150 man years of effort or something, right? And it had to be more generic to work across multiple applications. So it's a different problem to solve than I have at Google testing YouTube. If I want to test YouTube, I can build a whole team to figure out how to do that. The rest of us can't do that, because YouTube would be one of 1,000 things we have to test, right? And there'll be a new application tomorrow. So different problem in real industry. Second thing, we all hear shift left, right? The challenge, it's easy for Silicon Valley to say, I'm just going to have all my developers own test. I get that, because what you're paying your developers and what you can afford, and you can get the best developers in the world, blah, blah, blah. Sure, you can do that. But the rest of the world doesn't work like that. Developers are expensive and they're rare and you can't get enough of them. But we can add QA resources, and there are QA resources out there. So, you say, I got to leverage QA. How would I ever put this on the developers? And if I did, they'd quit, right? Yeah. So this idea
that's interesting. I saw a report last week that was talking about how developers are spending less time, I guess the term would be innovating, writing code, right. Because everything's been put on them now, testing, right. Security, now they have to, manage container systems and things like that. So, putting extra work on people is counterproductive, even though you think that that's where it should be. But I think anecdotally, it's the same thing in QA from what I hear, where, people are saying, well, I'm spending so much time maintaining these very brittle scripts and,
that's right.
and not really getting to look at the higher level of a lot of the test data and things of that nature.
That's exactly right. I mean, our view is we want to take the QA engineers and elevate them up so they're not stuck fixing brittle tests. And by the way, I mean, our industry created a brittle test mechanism. And I'm not blaming Selenium. It's a great tool. And, there's a bunch of things out there, but they're by their nature brittle. And it's no one's fault. It's what it is. So, so we had to look at that and say from the beginning, we have to think about this in a new way. And I'll show you, obviously you can't learn all about this in just, in the next 5 minutes. I'm just going to give you a little bit of an overview. But we separated our AI idea into two sections. One, we're going to machine learn the application. We're going to blueprint the application. It's going to be data driven when it does that. And it's going to do it at every new build. Now, underline that part, every new build. Mm-hmm. If the system can relearn your application at each new build, maintenance goes to zero, because there's no such term as maintenance, because the changes in accessors and anything else happen at each build, right? That's where the problem has always been. A new build brings with it all new accessors and all the X paths are broken, let's say. And you go, I have 2,000 scripts that I have to now go through one by one and fix. But if I am going to learn and write scripts automatically at each build, the concept of maintenance is specious. It goes away, because I'm going to throw that material away, except for setup and some templates. I'm going to throw it away on the next build and relearn again. That was quite the breakthrough here.
That's key.
Originally, we went out and said, let's learn the world's applications. And we learned nothing because it's noisy data. And then we said, well, let's learn the application once and then we'll look for changes. That turned out to be a maintenance headache. We were repeating the headache that people live with. And finally, we said, if we can make it fast enough, we'll just learn the application in 40 minutes every single time, every single build. And then we'll just write new scripts for that build and throw them away when they're done. And they'll be done an hour from now when you got another build. That was a total breakthrough for us. And it changed everything about maintenance, and even for AI scripts, maintenance headaches, et cetera, et cetera. So anyway, there's step one and step two, which is optional, but for existing applications, we can leverage just regular production logs, Splunk, Sumo Logic, W3C, et cetera. These are all standard. They're on your production servers. QA often doesn't know they're there, but trust me, they're there. There's no binaries in them. There's no PII. It's just gets and puts and posts. And it turns out, as you'll see, we can leverage that in a unique way. So at the end of this will generate thousands of scripts automatically based on what your actual users have done in production. And if it's a brand new application, you just blueprint it, because you wouldn't do a regression test, because there's no such thing as regression on a new application. So it works with brand new applications, it works with brand new features, and it works with existing applications by building up scripts that replicate as close as possible what your users did in production. That's never been done before. That's how we can write 5,000-6,000 scripts in 10 minutes, is we're leveraging and looking at what your users did in production. And there's nothing to add to your application. You don't outfit your application with anything that breaks all the security paradigms and causes it. No, just using stuff that you already have around. It's really fun. And,
so one of the attendees had a question and wanted to know, how do you know each of these new builds is correct?
Well, Well, you don't know it's correct. That's a great question. But what we can do is ferret out any errors, number one. So we're going to look for API errors, UX errors, JS errors, any other errors that occur. So it's possible someone created a new pathway that goes somewhere you don't want it to do. The second thing we're going to do is do validations. We haven't talked about validations yet. So validations tell you if things are working the way you expect them to work. I'm going to talk about validations in a second. And the third way is if you use the script generator, and by the way, the blueprinting generates its own internal scripts. So these are both script generators. One generates its own scripts from top to bottom. The other one generates scripts based on what users do. Third one is if users have been doing X, Y, and Z and coming out with this outcome, and then you've got a new build and that doesn't happen, that is, the script is written, but we'll flag that and say this is either it's impossible to write a use case that matches what your users are doing in production, or when we do, you get errors here, you get a failed validation. So I'm gonna have to jump to the next slide to talk about validations. So in scripting, we say assert exists, right? Everyone knows that term. I'm going to assert that this thing exists, and does it exist, and does it look like this? But in AI, we're looking at an application as a whole. We're not looking at a specific, say, use case. So if that's the case, we have to have different kinds of validations that a human would validate. So now we're thinking about a human walking through an application, validating lots of things throughout the application every time they see it, rather than script writing where we say, let's write one script, get to this point, check that works, and we're just going to assume that works throughout the application because it worked there. So now we're going back to the way humans work. And when we do that, we have three different kinds of validations. A data-driven validation where you have input fields and then validation fields. There can be n number of those. And there can be unlimited rows, unlimited columns here, unlimited validations. It basically says there is a user, they put in these things, and then we're looking for this data to come out at these different places. This can be OCR'd off of PDFs. It can be anything you want, right? It can be numbers, it can be letters, it can be words, it can be live data that comes in, by the way. Those fields can be live, so it can go pull data from somewhere. Very, very cool. And it will do it throughout the application thousands and thousands of times. So you're not validating it once, you're validating it every time it sees the opportunity to do so, both in blueprinting and in scripting. There's a thing called an auto validation where you just want to validate something maybe 100,000 times in an application. Here you want to see that you can go from this, you're clicking on a link that says take me to the non-repairable page, and it takes you to the non-repairable page. You want to make sure those match. That's an example of something that could be automatically validated 1,000,000 times throughout an application. Again, you couldn't write a script to do that. This system does it because it looks at the application holistically. And finally, there's something called an advanced validation. I'm going to give you one example. Advanced validations can work on dynamic data, dynamic screens, etc. This is an example. Those 4 boxes from Hear the Garth channel to 12 new shows, etc. could be anything from 1 box to 8 boxes. And that's dynamic by the second, depending on what's happening, news, this and that, right? So the system can do an API to UX validation. It can look at the API and say how many boxes, first of all, are there in the UX? How many did the server request to be displayed, and are they the right ones? And it will do it every single page throughout the application until it's done. So here's an example of a dynamic application where these boxes are fully dynamic in different order and different number on each page for each user, and it will validate each one each time, literally thousands of times. You couldn't do that manually. You'd do it 5 or 10 times, you'd give up, and you couldn't do it with scripting because you've got to compare API to actual what happened in the UX. But this is something that a machine is very good at, very good at. So you got to look at the things machines can do. And so I hope that answers the question. It was a great question, which is, it's right because you've set up validation so that even on the next build, you're validating certain things that say this application is indeed coming out with the right outcomes, if that makes sense.
Right. So one other, I guess, a follow-up question to that. So if you're rolling out a new feature, how does an automated system mimic the behavior of users if they've never used the feature before?
Exactly. So the blueprinter will actually go through that feature, but do it on its own, in its own way, right? It makes up a method from the start of the application, say logging in, all the way to where the end is. So it's made up its own way. It turns out even though it's got its own flow, it will give you back some very valid information, some very interesting information on server errors, server request errors or timeouts or JS errors, etc. But generally with a new feature, you're going to write a few scripts that really duplicate the user flow that product management or business analysts say is important to make sure it works, right? So that's an area where, again, you noticed up front, I said it doesn't get rid of all your scripting. You can't, my view is you can't look at AI to eliminate all scripting. What you can say is maybe AI can eliminate 20, 30, 40, 50, 60, 70, 80% of scripting. It can help maintain some other scripts. It can generate lots more scripts that mimic what your users really do, which is really powerful. So it's augmenting the work you're doing. It didn't eliminate it. It didn't take it to zero. And if you expect AI to take your work to zero, it's a false expectation. But I do think over time, you can see an 80% reduction or improvement, if you want, in overall QA productivity over the course of some period of time. But there's going to be a million corner cases that, no, you're not going to rely on the AI for that. And one case is I've got a brand new feature and I want this very specific flow to make sure it takes me to page 82. Great, you should write that as a script. And it will make its own way through it anyway, but you don't know how it's going to get through it. So I think you need to make that as a script. Okay, hope that answers the question. So these are big claims, but AI has the opportunity, and we've actually seen this to be true, 100% blueprint coverage of every action and every unique page. 100% coverage of every action and every unique page. This is without using any logs. There's no logs. This is just the AI blueprinter, okay? The second thing is if you have logs optionally, people do, but if you've got access to them, it will cover 100% production user flow coverage. We've never had that before. It's been the holy grail. What I want to test is what my users did in production, and I want to test those flows on this new build, or as closely as I can make them, because it's a new build. That is a powerful idea, and this system will absolutely do that. There's no question, and no maintenance on any of this because it re-blueprints at the next build. So, really powerful outcome. And these are, again, these are claims that you can't make any other way. So there are challenges that we find. So uniquely data-driven workflows might not be the best target, where the data itself filled out in a form may dramatically change what the next page is that is called, let's say. That can be challenging because we don't know what data, for example, a user put in production. So we can't reproduce that exactly. We're going to reproduce it with test data. If you're doing the sort of regression flows, the blueprinter will be fine. It'll just run with the data that you gave it, but it may not be adding as much value as you can add in other applications. Setup and AI hinting must be done by the vendor, not the client. By the way, this is basically true throughout the AI industry, not just for QA and software development. It's true in customer support AI. It's true in image recognition AI. It's basically all of these get set up by the vendor. It's a new paradigm for QA because people watching this webinar are going to say, well, I want to download a tool and push the button. It doesn't work that way. It takes a lot of time to set it up, and it takes people who've set it up thousands of times or hundreds of times. So it takes real experience to set it up. It is not something there's a whole setup procedure for AI hinting, and we don't even give that to our clients. That is included for free. Our team does that, and that works the best. And I can tell you, real AI across the industry, because I work across the industry, is done by the vendor. It's set up by the vendor. You run it, you kick it off, you're part of the team, but the people who actually put those in and put the validations in, it's really done by the vendor. So you're going to collaborate with a vendor. It's much more collaborative than let me download something and push a button. It doesn't work. Patience is a virtue in this industry. So kind of brings me to POCs, proof of concepts. And this is what we found. So set your expectations thoughtfully, carefully. My first point is real AI vendors don't work for free. If you can download something for free, it's not real. It's not going to be set up by anyone who's got years of experience. It probably doesn't have AI hinting, which means there's probably no AI in it anyway. Maybe there's a little bit of image recognition or something, but there's just nothing that's going to automatically generate thousands of tests that are valid for you without the vendor's very close involvement. just not going to happen. I can tell you, having done this now for a long time. What we have found is this often takes weeks to install. Sometimes it cannot be done as SaaS, although we offer a SaaS version, but a lot of times it has to be behind people's firewall. But even if it's SaaS, there are all kinds of issues in taking over applications and interrogating applications and whitelisting IP addresses, and just assume it's a few weeks before anything's doing anything. And then it may take months to learn and tune the thing. So you'll have something in 2 or 3 months, and then you'll have something much better in 6 and something far better in 12. And to add the validations that make sense, and to even share within your team the concept of validations and what would be important to validate. You have to kind of rethink that. It isn't just sitting there. And so we like to say, you know, in 1 to 2 years, you may have that 80% impact that you expect. And within a year, you might have a 20 or 30 or 40 or 50% impact. By the way, those are amazing. Those are amazing stats, right? You're going to save money, you're going to save time. But these people that I get people all the time, right? They come to us and say, well, I just give me the free download. There is no free download. It's a huge system. We'll work closely with you, but it's not free, number one. And number two, no, you're not going to have a huge outcome in a week. It's not that kind of thing. It's real AI. So you can already separate the real AI from the fake AI, sort of when you find out how people work through this.
Yeah. So let me ask you, is this like an impediment to AI when you go into people and lay it out for real for them? You know, again, talking about the difference between the myths and the realities, that it's going to be a year or more before they actually see any ROI, you know, because that's very important to companies. It's instant gratification. They're booking the expense in this year. They don't want to see the return 2 years from now.
Right.
You know, how do you kind of overcome that hurdle in an organization?
It's a great question. I mean, a lot of our customers are seeing tremendous gains in 3 months. But if you want that 80% impact, think a year. If you want a 20 or 30% impact, you might have that in a few months. And I think everyone
that's still very good.
It's unbelievable. What else could you do that would give you a 30% impact? Go buy it, right? I mean, that's the thing. Here's what I would say. CIOs know what I'm talking about to be true because they're already rolling out AI in customer support and sales and marketing, right? So they've been through these POCs in other fields, in other areas of the business. So when you approach, in fact, if you approach a CIO and say, oh, you're going to see a huge return in a week, they'll probably throw you out of their office. They'll go, you're crazy. I've done 28, AI POCs, not going to happen, right? Not going to happen. So at the C level, everyone knows this to be true. Give things time. AI is bleeding edge. It takes real vendors to set it up. And in fact, CIOs don't even want their people setting it up. Why would they have to learn how to set this thing up? There's experts who do this. And in time, we might teach you, but no, the vendor's doing it. That's what we're paying them for. So I think that's important. And they expect to start to see that ROI over the course of a year, and they'll evaluate at the end of the year if they want to continue. And if it's, if they've seen a 30% improvement and in the next year they're getting another 30%, they are jumping for joy. Like everybody's happy. But that's different than we've seen in our QA teams, which typically download something, try it for an hour, and then go, I don't know, I didn't make it work, I'm done. Well, this doesn't work that way. I can't change that. But it doesn't work that way in any field. So just think about, you're part of an entire thing that's happening, an entire shift in the industry, right? Oh, let me talk about the outcomes quickly, and we'll jump. Then we could do a bunch of questions. QA, these are real outcomes. QA runs that'll validate more than before in a tenth of time, absolutely. Find a lot more bugs, but are they important? So all of a sudden, QA engineers are stepping back going, this is a mature application. You just found 502 issues that we didn't know existed. What do we do with that? So we are finding absolutely more bugs than anyone has ever found. They had no clue. And they're real issues. And they do actually eventually fix them all. But at first they say these aren't real. They go, no, it's a machine. They're real. And here's the script to reproduce it. So that's fascinating, I think.
What about false positives? Is there any way to prevent that from happening? Like,
yeah,
how does
never say never.
That, oh, this is serious, or that's really not important?
Right. Never say never. I'd say it's a machine. It's just going to report that, there's a 502 error, right? Or 404, whatever, right? The error really happened. Whether you care about it or whether it happens a lot is where you have to get people involved. And now QA is working closely with the business analysts and dev to prioritize all of these bugs, right? So prioritization is a different thing. It's very hard for the machine to say, I saw this bug and it didn't actually happen. I think it's just a machine. right? It absolutely happened at that point, and there's a snapshot of it, and you can see a stack trace, and you've got a way to reproduce it. It's not inarguable that it happened. The question is, do you care if it happened? But it happened. So I think it's, it's not a false positive, but is it important? And that's where we need humans to work, because you got to decide, is it important? A machine can't do that for you. We just give you the data, right? Firms do rethink what their QA people do. More test data, better analysis, more tests, more validations. That gets to be where you're elevated. You're not just sitting there typing away trying to maintain tests. That a lot of that can go away. Not 100%, but 20, 30, 40, 50, 60, 70, 80% is a great goal. Key motivators, time and coverage. That is the motivator here. It becomes the cornerstone and decider of a DevOps pipeline and drives a continuous testing culture. I always talk about this in my broader talks, but I think it's true. As a professional, your job will not be replaced by AI, but you could be replaced by others who are leveraging AI to do the job. So, don't hold back is the thing, right? This is my last little thing. It's a little cartoon, but I want to handle a bunch of questions I see here. You can decide to lead the parade, be in the middle of the parade, or watch the parade go by. In this case, I guess the parade went by, but I would encourage you to stay in the lead of the parade. And the reason is as a QA professional, the last thing you want to do is have your resume be out of date. In fact, what you want to do is say, I led our company in investigating AI, and we went out there with, the leading thing we could find, blah, blah, blah. And over the course of a year, this is what we learned. This was hard. This worked. It worked on these applications, more challenging on these. These are the gains we saw. You want to be the leader who's doing that. You don't want to be behind and go, all these other people have AI on their resume. I don't have it because I was scared to do it, right? So I always suggest in people's career, get out in front and try to get people behind you all the way up to the CIO or VP or whatever you need to do. All right, we've probably got some questions, Dave. So let's get to them.
I just also first want to remind people that we're still taking questions. If you have one, just type it into the console, the control panel there, and again, we'll get to as many as time allows. We have about 5 to 10 minutes left. So let me just get started with what is out here. And so maybe you could talk people through the creation, the automated creation of tests, because that's obviously unique to the code that you're writing. So where does that happen and how does that happen? Is this test-driven development of people writing tests and passing the test and then writing the code, or?
Sure. So all of this happens post-integration. So we're not talking about unit tests here. We're talking about an integrated application, fully working, and these tests are not against your source code. And we're talking about web applications. We're talking about mobile web. We're talking about mobile native, right? That's set. We're not talking about thick clients today, .exe, blah, blah, blah. We've really focused on all the modern application frameworks. And so there's two types of testing: that blueprint testing that will go through your application, but writes its own tests, and it writes its own in ways that have very little to do with what users would really do, but is all validated and is data driven. So you can imagine how that might work, but it's a little bit like putting a tester on the application that doesn't really know the application. You just say, go through it in every which way you possibly can and fill out every form, and they will, and they'll find problems, right? So the blueprinter will do that. It'll start in the right place, it'll end in the right place, but in between it's made up hundreds or thousands or millions of pathways. And then the optional thing, second to that, is after learning the application, is this regression test generation. And that, of course, is based on looking at production logs, which the first one is not. So you don't need production logs, they're optional. But if you have them, you get another set of tests generated that's true regression that we've never had before. And that's a breakthrough. And you can go, by the way, you can just go read our patents on this. We've got kind of some of the seminal patents in the space, and it's very detailed in there of how this works and how the algorithms work. So it's not a secret. You can go read it in the patent. But it's really powerful. So we can take what happened at the API level and upscale that to an end-to-end test. It's fascinating. Now, how can we do that? Well, we can do that because, remember, we just learned about that build, which means we were able to tie actions at the UI to actions and reactions at the API. And so now we can remember that in our blueprint file. We can bundle that together into individual bundles and say, I've seen these 200 requests happen before when someone filled out this form. So that tells me that from the production log, someone must have filled out that form in order to get to that next page. Therefore, I'm going to write the script that way. And when the machine starts doing that, it's very, very fast. And it's not unusual to generate 3,000, 5,000, 10,000 scripts in just a matter of minutes, and then run them. And we'll run them in parallel. People say 10,000 scripts will take all night. We can run 10,000 scripts in parallel if you want, if your QA server can deal with it. And so it could be 5 minutes if that's what you want, or you run 1,000 in parallel, it'll be 10 times that, it'll be 50 minutes, whatever. So it's not long when you've got parallelization like this. But great question. That's how they're written anyway, and that's fun. Okay.
Yeah. So another question from one of our attendees is, how do you deal with the issue of duplicate issues? He writes, as I assume each time you're running a brand new script, you're producing a high percentage of bugs that are duplicated. So how do you handle that?
Great question. So here's the thing. There are no duplicate use cases. So the first thing is that all duplicate use cases, including sub-use cases, are eliminated from the scripts. So in those 5,000, the system might have generated 50,000 scripts, but threw away 90% of them. And the reason for that is that many use cases that we find in production are stubs of the longer use case. So I might have a long use case of 100 steps, let's say, and within that, there were many 10-step things that those use cases get thrown away. We don't need them because they're buried within the longer run, if that makes sense. So you're not going to have any duplicates in the use cases. So that eliminates part of the problem. And then you could have duplicate bugs, but those duplicate bugs happen in different use cases. And so we're going to post those in a report, and you can see the use case that happened. You can see the page. You can see the stack trace. You can see everything about it. So you are going to get a report with the full, including a validation report with all the ones that passed, because it turns out our customers want to know which ones passed. And there are thousands of places where it passed and a few where it failed. And you need to know as much where it passed versus where it failed. You can also sort these reports, and you can set end goals of pass fail so that your CD system goes on or doesn't go on. So there's a lot of things we didn't talk about today, but you have a lot of.
So a lot of your testers now are going to become people who are analyzing these logs and then figuring out. Again,
you want to analyze the reports, and right. I see a question here. How does this work for RESTful messaging or microservices? It's a great question. So the whole system for now was built around applications that have a UI. And so right now it does that. But what I didn't tell you is that all of the tests are written at the end-to-end level, at the UI level, and at the same time at the API level. So in fact, everything we talked about today can be done at the API level, but today only for applications that have a UI, either a mobile application or a web application. So in fact, we do talk REST fully, right? Quite nicely. That's a pun, actually. That was very good. And we do that, but we only do it for UI-based applications that have a RESTful interface, if that makes sense for now. But one could imagine, since we already write all these tests at the API level, this could be extended. But for now, there's just so much demand there. I think we might have time. Do we have time? We got time for one or two more.
Yeah. Again, I would just remind people, if they have a question, they could type it in right now, and we'll get to it while we're hanging out here. So while we're waiting for that, Kevin, let me just kind of throw this out at you. What would be the top takeaway from our presentation today? The one thing that you really want people to understand about incorporating AI into their testing?
Yeah, have realistic expectations. You have to have a budget. It's not free. We don't work for free. There are people who do. I don't know. But you don't work for free. We don't work for free, but we'll work with you together. But have realistic expectations. You will learn a lot. We would not take anything on that we're not going to be successful with. I'll just speak for ourselves, right? So if we take it on with you, we know we're going to be successful. And patience is the best virtue here. This absolutely works. Absolutely works. Period. Full stop. And there are a lot of places that won't work. We're not going to work with you. Not that we don't love you, but we can't work with you right now. We can't do everything, right? But if it's a good match, we're going to work together. We're here to make you successful. And I hope that's true with any vendor in the space, but that's our goal. And so we want to have a success out of a POC, and we want that to become a production system and core to what you do. So yes, it works. That's the key takeaway. Have patience. There'll be ups and downs. There'll be days when you go, oh my goodness, I can't even talk to the application, but everyone will get through it. All be fine.
Right.
By the way, there's a great question here. If I can chime in,
Yep.
David. So I just
Exactly.
how do you ensure 100% code coverage? Great question. We do not ensure 100% code coverage. If you looked at that slide, I was careful in my words. It's 100% user flow coverage. That's completely different than code coverage. Now it's fascinating though. Do we care about code coverage if over the last 10 weeks no user went there? I don't know. I'm not here to answer that for you. What we said is we can give you for the first time 100% user flow coverage. This is what your users actually do in your application. Maybe no one goes to the shoe store. I'm making it up, right? To simple. Maybe no one goes to the shoe store ever. Do you even care to continue to test it? Well, you can. Obviously, you can write scripts. But in AI, we are going to test it in blueprinting. But in regression, we won't, because the definition of regression is to do what your users do in production and do it against the new build. So by definition, we won't go to the shoe store if no one ever went to the shoe store. Why? Because no one ever went there. That, by the definition of regression, there's nothing to regress to. There's nothing to test. So
Right.
I know you probably find that funny, but think about the definition of regression. We're doing exactly what it's supposed to do. So I can assure you that the system went through 100% of pages, 100% of the data you gave it, 100% of every action, and then separately with regression, went through 100% of user flows that your users do.
Mm-hmm.
So you might want to rethink, what is code coverage? What is coverage is a better question for the industry. So anyway, there's
So we have one final question that we have time for, Kevin, and that is somebody was wondering if this could be applied to testing other AI models themselves, because that's an area that QA people are struggling with.
It is. It's a huge area that QA people are struggling with, and the truth is we haven't given that much thought. Actually, the problem with testing AI systems is the outcome is determined on a set of confidence scoring. But if you can think of all the math that goes into AI, all it does is learn from the past and apply it to something new with confidence scores. So for instance, when we look at the past logs and we look at the blueprint, we believe with a reasonably high confidence that someone must have pushed this button at this moment in time, right? We just believe that. We could be wrong, but it turns out with 5,000 scripts at some level, it doesn't matter because the coverage gets very high. And if you didn't grab it this time, you grab it next time. But through a set of math, we've got the highest confidence that it was that button versus this button. That's what's going on, right? And so it's a great question because the outcome of AI you can't determine. So you would have to set up a system of data where you could absolutely determine what the outcome was supposed to be every time. So you forced you forced the machine to learn on a known data set, and then you forced it to essentially report on the results, and you knew what the results were going to be, right? You'd have to fix all of that stuff. And then you could test it every time and say, is it still working the way it's supposed to on known data sets? That's how I would do it. And then, yeah, I suppose you could use this. But yeah, it's a struggle for sure. It's a struggle for us, by the way, because testing applications every day is a new application because your dev teams keep writing new applications with new libraries and making our life hell. But that's okay. That's our job. That's what we took on.
Right. Great conversation, Kevin. Thank you so much for being with us today. Again, Kevin Surace, CEO at AppVance. I'm Dave Rubenstein, Editor-in-Chief of SD Times. Thank you all for hanging in there and asking some really great questions. Yeah. So until next time, so long, everyone. Thank you, Kevin.
Thank you much. Thank you much, Dave.